Well, Professor Huberakis, first question I would like to ask about what do you think about scientific research presently? Scientific research in world nowadays.
Well, there is
How the progress?
enormous progress in many fields. Whatever we look at in physics or chemistry, biology, biochemistry, astronomy. So exciting news. We read about, and I'm quite sure it will continue because the tools and the instruments are becoming better and better. But at the same time, the size of the problems increases. So there is not less work with the improvement of the tools. We will work on larger and larger and more complex problems. Now, biology is an example of that, and in particular my field of research, that is structural biology. Now, we started in the late 60s with very small, abundant proteins. Now we work with proteins that are very rare because we can make them recombinantly in bacteria. We work with very large proteins which are sometimes 100 times larger than the proteins we worked on at the beginning. And this kind of development we see in all other fields as well. Think of computer technology. When I started, there were actually no computers available. And now and when the first computers became available for our research, they were very, very primitive.
So it's like protein engineering, right, Professor?
Protein engineering comes in, so the gene technology, we can change proteins at will, modify their function. We can work with animals, with mice. We can knock out certain genes and see how these animals behave. This is very important for human health, for instance, and drug development, understanding diseases.
Yes. Is it still there's a bigger challenge in especially in proteins?
Well, there is an ever-growing challenge. So we learn more, and we see that the field widens. So there is no end of research. I mentioned today the problem with antibiotic resistance. This will be a continuous fight forever, I would say, because once we have a new antibiotic, then these very clever bacteria and viruses develop and escape. So we have to find out why does a pathogen escape. We have to look at it, analyze it, and then develop a new antibiotic. Bacteria don't wait. They will find resistance against the new antibiotics. This is an ongoing, forever ongoing problem. Food, energy. So population grows, and we have to feed them. These people, I think we can. Energy. Fossil energy sources will be depleted sooner or so you will, not my generation, but your generation, it may happen at least concerning oil and gas. So we have to find a replacement.
And how about Indonesia? What do you think about scientific research in maybe in third country like
Yeah.
Indonesia and Malaysia?
Well, you have the wonderful potential of the many young people in you. European population, if one looks at the fertility of European families, then Europeans will die out. It's a huge, beautiful country. Just come. So this is a great thing with Indonesia, this wealth in young people. Of course, it's a developing country, and it's quite clear that research needs to be developed further. But research is done by researchers, by scientists, by brains. It needs support. I hope politicians will learn that this is necessary for the development of the country. So there is the natural beauty of Indonesia, which I very much enjoy, and probably tourists enjoy it too.
And how about ITB, Professor? I mean, you have come to here and you've watched chemistry, biology in here. Perhaps, what do you think about
Well,
ITB?
what I saw, what impressed me at the ITB, I just saw the ITB, is the natural product chemistry, where they make use of the biological diversity that is in the country. This is a great advantage. This is a big wealth of the country, this diversity in a tropical country, and obviously they are successfully isolating and collecting, isolating these natural compounds and doing preliminary tests of biological activity. There is this is a great source of finding new drugs.
Especially there's a lot of bacteria in here. Yes. Okay, I think that's all. Thank you, Professor.